All right, I am going to record this session too. So, I've started the recording. And just to repeat, one of the questions that was asked earlier is, are we having the in-person portion of the exam on Wednesday? And the answer is yes. Um, in case you didn't see the email, I got sick over the break. I got COVID, or I tested positive for COVID. So, they required me to quarantine for a few days, and the window is 10 days, which for me actually ends tomorrow, which means I should be back, in person on Wednesday. So apologies for, this online meeting. There's not really much I could do about it, I guess. But so we'll meet online today, and then on Wednesday things will be back to normal in a sense. So we will be there in person. If for some reason I happen to not be there, somebody will be there to hand out the exam. So there is in-class portion of the exam on Wednesday. So actually that leads us into the first topic for today, is just to take a look at the schedule for Math 5. We've looked at this various times throughout the semester. And so where are we? We are almost done with the class, right? December 5th is today. We're going to review Module 3, which means, we can go over worksheets 5 and 6, or the practice problems that are posted in the announcement. And then the next meeting that we have is going to be our last meeting, going over exam number 3. Exam number 3 will be very similar to exam 2 and exam 1 in the sense of the structure of the exam will be the same. So we'll have that on Wednesday. Okay, and so there will be an in-class portion and an online portion. All right, let's see. So let me go ahead and go over real quick to the there was a excuse me, there was an announcement put out by David Hambley saying, that the exam is coming up, right, on Wednesday. And so just keep in mind the things that are available. There are lots of office hours, lots of Math 5 instructors are available, myself included, since I'm online. Right now it's online office hours. But there are office hours at that was not going to work for us today. After this class, immediately following this class, there are instructors who are available. So Monday and Tuesday, we have some instructors who can who can help you with some of this stuff. Okay, so and let's see, we also have the Math Center available. Need a little bit of help, you can go to the Math Center. Can everybody see my screen? Are you able to see that? I should be sharing this. Just want to make sure before I get too far. Okay, cool. All right, and then there's a practice exam on ALEKS, which you can access. This has been true for every single exam. We will go over some of the practice problems together, whichever ones we want to go over. There's a reference sheet that you can download. This is what you can look at during the online portion of the exam. So if you need that, there might be some helpful formulas on there. You can use that. And then something that was kind of nice I saw on here is that you can use anything provided by your instructor, such as videos. I've been posting videos on YouTube. You can watch those. Just go to my channel and you can see all the latest videos. But David Hambley also made some videos, and they're really good. So you can click here on that announcement, and there's some that are for worksheet number 6, and then some for worksheet number 5. So if you want to see somebody else, talk about the material, David Hambley has been teaching Math 5 here for a long time, so you can watch those videos, and they're a great resource. Okay, so are there any questions? Yeah, just any general questions that you would like to ask. There's also this preparing for exam 3 announcement. It is very similar to the exam announcements that we saw in the past. So I think this is our third exam, so we should be pretty much set, in terms of what's going to happen. It will run as usual. The in-class portion will be in class, and the online portion will be online. Okay, so don't worry about that. All right, so worksheets 5 and 6 are what we can cover today, and then there's also a set of ALEKS problems that we can take a look at as well. So really whatever you all would like to look at, we can do. So maybe I'll jump in here and just do one of these problems kind of at random. And could we also do question 7? Is that question 7 if we have time? Question 7 from here? Yes. Sure. Yeah, we can take a look at that one. Let's go ahead and warm up with maybe let's see, is there a basic one? Okay, actually we can just start with question 7. Yeah, that's a good one. And this one here actually goes over something that we did not cover in this class or in the discussion, right? So this is a horizontal shift. Right? And this is going to shift the graph to the left pi over 3 units. Okay. And so basically what we need to do then is let's take a look at the basic sine function, and then we can apply these two transformations. Once we know the basic sine function, then we apply these two. This is going to be the amplitude, or this will give us the amplitude, it's the absolute value of that number 3, which is 3. And so that tells us, how much it's vertically stretched. Okay, so two things there, not too bad. So here is the graph of the sine. First of all, what's the period of sine? Let's say f of x equals sine of x. What is the period? Does anybody remember that? It is 2 pi. Yes, 2 pi. And some people, I think, yeah, 2 pi over b you might be mentioning there. If there was a coefficient here, sine of bx, then it would be 2 pi over b. We adjust it with that b. In this case, b is 1, so it would just be 2 pi. Yep, good. And then the amplitude for the basic sine function is just 1. So one other thing that I want to mention, because sometimes we kind of get a little bit stuck on, how do we label the x-axis and the y-axis. The x-axis, I used something that I called the horizontal increment. And it was basically just taking the period and dividing it by 4. And so this is going to be 2 pi divided by 4. If you reduce 2 over 4, you get 1/2. So it'd be 1/2 pi or pi over 2. And so this is the value that we're going to use along the x-axis, pi over 2, pi, 3 pi over 2, and then 2 pi. The amplitude we said is 1. So this is just, kind of giving us a little bit of a review here. And so now we can graph. We remember sine starts at the origin. It goes to its maximum, goes back down to its 0, then to its minimum, and then back down to its 0, or back up to its 0. And so the sine function looks something like this. This is just a little sketch. So all we have to do now is stretch this vertically by a factor of 3, and then shift it pi over 3 units to the left. Okay, so what I'm going to do here, let's see how many 1, 3, 4, 5, 6. If you take a close look at how many tick marks that are given, they're giving 6 tick marks to get to pi. That means that each one of them is pi over 6. And so that means that the second one is 2 pi over 6, or if you reduce this, pi over 3. And so this is perfect because all we need to do is shift this graph to the left pi over 3 units. Okay, and so we'll shift it 2 tick marks to the left, and that will be our graph. Okay, so let's go ahead and do that. Let me just sketch the graph. We know that usually the sign starts at the origin. The period, the period of this is going to be just 2 pi, since the coefficient in front of x, that's b, is 1. So the period is 2 pi over 1, or just 2 pi. So pi over 2 units is halfway between 0 and pi. Let me go ahead and mark that on here. This is pi over 2, pi, 3 pi over 2, and then 2 pi is there. So our graph is going to look something like this. Up at its maximum, which is now stretched by a factor of 3. At pi, we reach our 0 again. At 3 pi over 2, we reach our minimum value. And then at 2 pi, we kind of reset there. So we have this as our graph, and then we still have to shift it, but we're going to shift it in just a moment. Just like that. And then we shift pi over 3 units to the left, which we said is just 2 tick marks. So let me go ahead and just take this whole thing, shift it 1, 2 units to the left. And I'll delete this now because they're now off. Okay. So this is our graph. Excuse me. All right. And if we wanted to know what each of these, what each of these coordinates of these points are, we can just take, we said, 2 tick marks was pi over 3. So we can just figure out what 2 pi minus pi over 3 is to figure out what the coordinates of this point are, this last point. For sure, this first one is negative pi over 3 because it was at 0 originally, and we went back negative pi over 3 units. So if we want to figure out what each of them are, we can just do, what the original one was, 2 pi minus pi over 3. Now we'll have to do a little bit of fractions here. 2 pi over 1, that's the same thing as 6 pi over 3 minus pi over 3. So 5 pi over 3. Excuse me. And so on. 3 pi over 2 minus pi over 3. We would need a common denominator of 6 there. So that would be 6. Let me show my work here so I can make sure not to make a mistake. If I multiply by 3 and I multiply this by 2, they would both have a denominator of 6. So 9 pi over 6 minus 2 pi over 6. This is 7 pi over 6. We only have 2 left, so I might as well do the other 2. The middle one is usually pi. I'll write it as 3 pi over 3. That's pi, and we subtract pi over 3, which gives us 2 pi over 3. And then finally, pi over 2, I'll write that as 3 pi over 6 with a denominator of 6 because we know we can get a common denominator here, 2 pi over 6. And we have just pi over. Yeah, and that's actually exactly what it should be, because we said earlier that one tick mark represents pi over 6. All right. All right. Any questions there? I mean, the graphing of it, I don't think was too bad, as long as you know the basic sine function that we've graphed up here. All we did was two things. We stretched it vertically to 3 times the y value, and then we just shifted it pi over 3 units to the left. Any questions there? For the student who asked this question, is that okay there? All right, very good. All right, what other questions might you like to see? I can also go to worksheet number 6. Feel free to put it in the chat until somebody puts something in the chat. I'll just work one out myself. Because these are all good problems here, and I know I was gone one of the days that we had a little mini lecture. So let's take a look here at one of these problems here. Let's say this problem, 6a. It says find the exact value of each trig function in radians. Use the unit circle. Okay, so the cosine inverse of 0. What is the cosine inverse of 0? Well, this quantity here. Sure, yeah. Somebody asked, can you do one of the word problems? I'll do that next. Yep. This quantity here represents, this is an angle. Our answer needs to be an angle, and I usually like to call it theta, in the range of cosine inverse. The range of cosine inverse is from 0 to pi. This was talked about in that video that I posted a while back. So an angle from 0 to pi, that's quadrants 1 and 2, where the cosine of that angle in question is equal to 0. And let me put the 0 in a different color just so we can kind of see where the 0 comes from. This 0 is coming from the argument there. Okay. And so all we need to do is look at the unit circle and try to find an angle whose cosine is 0. This can actually be done without the unit circle, but we'll use the unit circle just because it's provided. So remember, the range of cosine is something you have to memorize. It is from 0 to pi. And so that includes, pi over 2, of course. It is in quadrants 1 and 2. And so you look in these two quadrants, somewhere in these two quadrants, there is an angle whose cosine is 0. Now remember that in the unit circle, the x and y coordinates represent the cosine of an angle theta and the sine of theta. And why is that? Because remember, cosine was x over r and sine was y over r. But r was equal to 1. So then really just x comma y represents cosine and sine. Okay, so just a little review there. And so if we go to the unit circle, can you look through quadrants 1 and 2 and tell me which angle has a cosine of 0? Which angle has a cosine of 0? And you can put it in the chat or you can use your microphone, whatever you like. We're looking in these two quadrants here, and really all we're doing is we're looking at we're looking at which angle has an x coordinate of 0. And there's only one of them. Yes, very good. A few people are answering now. Pi over 2 is the answer. Pi over 2, you can see the x coordinate is 0. Some people answered, I saw 90 degrees, 180 degrees, 180 degrees. The cosine of 180 is not 0, it's -1. And then also for 0, the cosine of 0 is 1, not 0. So the only answer here is pi over 2. So this implies, yeah, the answer is pi over 2. Let me go ahead and go back to this. So really, there's not really much work to do in a sense. There's a lot of background knowledge that we have to have. But yeah, there's no, we could think of all of this stuff in our head in a sense. So let's do one more. Let's take a look and let's use cosine again if there is one. Okay, here we go. Let's take a look at this one here. I'm not going to write anything down for this one, just the answer, because it's the same two quadrants. We're still looking in quadrants 1 and 2, and we're looking at the x coordinate. So for cosine inverse of -1/2, which angle in quadrants 1 and 2 has an x coordinate of -1/2? Does anybody see it? Let's see. I see a couple answers there. Yes, the only answer, yeah, so two people, good, answered correctly. It is 2 pi over 3. 2 pi over 3 is the correct answer because the x coordinate is the one we want to be -1/2. Now, other answers, there's only one answer to this one, and the answer is, 2 pi over 3. Now, let me just go over, some people sent me private messages, which is fine, with answers. It cannot be, maybe somebody might have thought 4 pi over 3. If you look at 4 pi over 3, the x coordinate is -1/2. But 4 pi over 3 is not in the interval from 0 to pi, right? 4 pi over 3 is beyond pi. So it can't be this answer because it's too far. Same thing, somebody else answered 11 pi over 6. Yeah, 11 pi over 6 actually does not have an x coordinate of -1/2, so it can't be the answer either. So the answer there is 2 pi over 3. All right. And feel free, if you have a question on any other problem, just type it into the chat. And I'm just trying to make sure we understand this inverse trig function here, since I know I missed that day. So I just kind of want to gauge where we are with that. But feel free to type in, if you want to see problem 10 or whatever on worksheet or the Alex problems, that's fine. So let's take a look at one more here in the meantime, while we wait, in case somebody else is thinking of another problem. 6b is a good one. And some of these, at least these beginner ones here, don't require too much work. But when we start looking at a different inverse trig function, well, now we have to just kind of rearrange our thinking a little bit, because we're going to be looking at two different quadrants. We said 0 to pi, quadrants 1 and 2 for cosine, yeah? But for the sine inverse, what is the range of sine inverse? So for sine inverse, we're looking for an angle theta in the interval from negative pi over 2 to positive pi over 2. So we're looking for some angle where the sine of that angle is equal to that ratio that's inside of the sine inverse function, the square root of 3 over 2. So if we graph negative pi over 2, 0, and positive pi over 2, That's looking at quadrants 1 and 4. And so let's all take a look at quadrants 1 and 4. Can we see an angle whose sine is square root 3 over 2? And first of all, is there a quadrant that we could eliminate? Remember that sine of theta is equal to y over r. So yeah, which angle has a sine of square root 3 over 2? All right, I'm getting a couple answers. Yeah, and you can see Lath there replied to everybody. And it is pi over 3. That's correct. Yep. Because if you go to pi over 3, the angle pi over 3 here, I'm going to use my cursor. Pi over 3 here, the sine is represented by y. And so that's exactly what we want. Square root 3 over 2. There it is. Yes, that's the answer. Pi over 3. I saw somebody answer 5 pi over 3. I think that was a private message. Yeah. And it could not be 5 pi over 3 because the sign there is negative square root 3 over 2. And this one did not have a negative in it. So if it had a negative, that would have then we can use that for the to help us find the answer. But in this case, the answer is pi over 3. Okay. Any questions there? So cosine is only quadrant 1 and 2, yes. And sine is quadrants 1 and 4, yes. The inverse cosine and the inverse sine are defined in these, or they have output values only in these two quadrants. Yes, and that's why I wanted to go over these problems here, because you really need to know which quadrants, because if you're looking for an angle, and let's say you're doing a cosine problem and you're looking for an angle in quadrant 3 or 4, then that's just wrong automatically. Like if you pick an angle in those quadrants 3 or 4 for this cosine inverse, then it's gonna be wrong, and so yeah, we do need to know that the ranges of these trig functions. Okay, so let's take a look at, can you do any problem from 6 on worksheet 5? Sure. Yeah, so the next question here that came up is any problem from 6 on worksheet 5. Yeah, we'll do that next after just one more of these, and then we'll move on to that question there. The last one here is just a tangent. Might as well take a look at the third trig function. There's only 3 of them. I mean, there are 3 other inverse ones, but only 3 covered here on this worksheet. So we'll go over the tangent inverse. What is the range of tangent inverse? So let's see. Tangent inverse of -1. This is equal to, again, this is an angle theta. The answer to this problem here is an angle theta. And the range is very similar to sine, -pi over 2 to pi over 2, except we're not actually including the endpoints because there are horizontal asymptotes there. Oh, thank you. Yes, those smoke detector batteries are dead. Yeah, I've been meaning to, yeah, I'll change them. I'll change them very soon. Thank you for that. I just haven't gotten around to it. Yes, it is important too. So the angle theta in pi over 2 to pi over 2, where the tangent of this angle theta is equal to -1. So now we need to look at negative pi over, oh, and I know I'm covering it there. We need to look at the 2 quadrants that encompass -pi over 2 and pi over 2. And that's actually basically just quadrants 1 and 4 again. So that's kind of nice. Sine and tangent have very similar ranges. And so we want to look inside of these 2 quadrants here. which of these two quadrants is going to have our answer? If you watch the video, I believe I gave the acronym all students take calculus, and it tells us where the trig functions are positive. All trig functions will be positive in the first quadrant. So it's not going to be here because we're looking for where tangent is negative. That means it's going to be in quadrant 4. And so we need to look into quadrant 4 and find an angle whose tangent is -1. And remember, tangent was defined to be y over x. And so let's look in quadrant 4 here. Is there an angle here? When you divide the y value by the x value, it gives you -1. Very good. Yes, 7 pi over 4. Now, very good. Yeah, somebody else commented 7 pi over 4 or negative pi over 4. Yeah, Lath, that's correct. The actual answer is negative pi over 4 because if we were to answer for right now temporarily, I'll write down theta, equals 7 pi over 4. But we notice that 7 pi over 4 is actually this angle here, which is too big. It's outside of negative pi over 2 to pi over 2, right? We rotated past pi over 2 quite a bit to get to 7 pi over 4. So how do we deal with this? What we can do is we can just measure the rotation in the other direction. If you went 7 pi over 4 units, then that's negative pi over 4. And if you're wondering how we got that, you can just use the idea of coterminal angles, where we subtract 2 pi. Let's take away one rotation to make this angle a little bit smaller. And when we do that, we need to get a common denominator of 4. And we can see that that second fraction would be 8 pi over 4. If we do 7 pi over 4 minus 8 pi over 4, we get -1 pi over 4. And that is our answer. We do need to make sure that our answer is inside of the range of that inverse trig function. All right, so hopefully, is that okay there? Any questions? All right, so somebody asked for problem 6, or sorry, problem 6 on worksheet 5. So let's go ahead and take a look at that. And if you have any questions, feel free to just put them in the chat and I'll jump to it next. So yeah, is there a specific one you would like to do, in problem number 6? We can do any of them. I mean, it doesn't really. Okay. Yeah, so we'll just choose, let's do 6A. They're all basically the same. So the idea here is we're going to need to use, let's say, let's actually draw it here. Let's draw the situation. It says find the missing coordinate for a point on the unit circle in the stated quadrant. So we're in quadrant 4. So I'll draw quadrant 4 nice and big. Here's quadrant 4. The point, it gives us an x coordinate, and then the y coordinate is missing. So at some point, the x coordinate is positive 3/5. The y coordinate, if we're in quadrant 4, is going to be some negative value. So keep that in mind. Y is going to be negative. We can write a note here. Y is less than 0. And the point is going to be here in the 4th quadrant. When we get this information, we could draw a ray or a little line segment to the origin. And the reason that we can do this is, or the reason why it's a good idea to do this, or why we might think to do this, is because we're told that this point is on the unit circle. So this point is on a circle here, on the unit circle. So what is the distance? Let's call this r here. Does anybody know what this distance r is from the origin? Yeah, a couple of people answered. That distance is 1. So because the unit circle has radius 1. And so if we draw a triangle with the x-axis, then the x distance is 3/5. The y distance is unknown, but we know it's negative. Well, this is a triangle here. We can use the Pythagorean theorem. X squared plus y squared equals r squared. And so we plug in our x. We don't know the y, and we know r is 1. So if we plug this in, we should square each of these quantities and solve for y. So we have 9 over 25 plus y squared equals, let's say 1. 1 squared is 1. So we subtract 9/25 from both sides. And in order to subtract, we're going to have to write 1 as a fraction, 1 over 1. We multiply by 25 on the top and bottom. And so we get y squared equals 25 minus 9 is 16. The denominator is 25. And when we take the square root, what do we get? Y equals, can somebody tell us? What's the square root of 16 over 25? All right. Very good. We got a good number of answers. Now, we do get 4 over 5, as a lot of people said, but yes, there should be a negative there. Very good. Yes, nice. Some people put plus or minus. Yes, the negative is very important. Technically, yeah, the answer is plus or minus. You know, I left that off purposely to see if you'd remember. Plus or minus 16 over 25. But since we're in the fourth quadrant, y is negative, and so we would have a negative answer. So this is our answer there. So for the student who asked that question, hopefully that answers your question there. All right. What other questions do we have? And they can be even general questions, whatever is on your mind. Excuse me. In the previous class, which actually I'm recording this, I'm going to post it on YouTube, you know, after this class. So you can, if you want to watch what we did in the 8:30 class, you can. We actually did one very similar to this on the Alex practice problems with the other class. It was this one here. Question number 5 out of 30 is yes, please subscribe, you know, make me famous. Question 5 was very similar. You know, the exact same thing, basically the exact same question. So it just reminded me of this problem. Feel free to watch that video as well, if you want some more problems. All right, what else? Maybe I can look through this thing here and try to find some nice problems. Oh, some of these are a little more challenging here than what we did in class. But of course, that's, you know, that's how Alex is. Maybe we can take a look at one of these here. Let's start with number 17. It says, let 3, -7 be a point on the terminal side of theta. Find the exact values of sine, cosecant, and cotangent. So, okay. Well, what quadrant is this in? 1, 2, 3, or 4? This point is in which quadrant? All right, Diego says quadrant 4 is correct. Very good. And so we could, if we wanted to, you know, draw that triangle that we kind of stated earlier and say, okay, the distance in the x direction is 3, distance in the y direction is 7 units, you know, in the -7, so it's downward. And so now we can find, what's the value here of the hypotenuse? Can somebody tell us the length of this hypotenuse? And I was trying to trick you. Maybe everybody, you know, is not getting tricked here. So we need to use the Pythagorean theorem here to find the value of, let's say, r, because in this case, we don't know that r is 1. It actually is not. It's not 1. And so we need to find r using the Pythagorean theorem. So 3 squared plus a negative 7 squared equals r squared. So this is 9 plus 49 equals r squared. So r squared equals 58. And then we take the square root of both sides. Here, when we take the square root, again, plus or minus, which quantity do we want, the positive or the negative? Excuse me. Yeah, somebody said the positive one. R is always positive. So yes, it would just be the square root of 58 in the positive ones, the square root of 58. R can never be negative, just by definition. Okay, and now we're ready to find the value of sine of theta. Not too bad. Sine of theta is y over r, so y divided by r. On ALEKS, since this is an ALEKS practice problem, we should rationalize this. I did say in class for an in-class quiz or in-class portion of the exam, you don't have to rationalize. I don't really care if you do that. But on ALEKS, you do have to. It will mark you wrong if you don't. So we'll do it here. Since this is an ALEKS problem, we can multiply by the square root of 58. And we get negative 7 square root 58 divided by 58. It's only one more step, really. We could check to see if we can, excuse me, simplify this, but it doesn't simplify at all. Okay, and then what's the cosecant of theta? Can somebody tell us what the answer is to that one? Remember that the cosecant of theta is just the reciprocal of sine. Since we just found the sine, yes, very good. All right, good. We have some agreement here. The square root of the opposite of the square root of 58 over 7. Yeah, we can just flip that one over. No problem there. Nice. And then finally, the excuse me, the cotangent of theta. This one we could have actually answered as soon as we got the question, right? Because the cotangent, the cotangent of theta is just x over y. And we were originally given x over y, or x and y at the beginning of the problem. It's just 3 over negative 7. We didn't really even have to do anything for that one. We did have to find r for sine and cosecant. So, we had to find it, but yeah, the cotangent was clear from the beginning. All right, very nice. I think this is a nice exercise too here, number 16. Nobody is putting any questions in the chat here for other problems. So I'm just kind of just randomly picking problems. So number 16, part A. Oh, let's see. It's I got a question here. It says the negative doesn't stay with the 7. It applies to both still. The negative technically comes in because of the 7. Are you talking about in the cosecant of theta? Here, yeah, notice I put the negative up in the square root of 58. Yeah, and this is kind of a question. This is correct here, but if you want to be a little bit more, yeah, maybe a little better, we could write this as the square root of 58 over negative 7. It turns out that these two fractions are they have exactly the same value. But in blue, that one, in a sense, it would make more sense to write it that way. So yeah, if you want to write it that way, you can. You could also write the negative in front of the fraction like this, and not put it on either number. But the negative is there because the 7 is included. So yeah, if you prefer this answer here, this is a good answer here. Yeah, I guess I kind of just moved it somewhere else, but as long as there's only one negative, yeah, it applies to, it can be applied to either number, but the reason that the negative is there is because of the 7. Yeah, the 7 is what brought the negative in. Yeah, good question. That comes up often. Yeah, as long as there's only one negative in there, it's correct. All right, very good. All right, so let's take a look at part A of number 16. Yeah, and maybe just put in the chat which quadrant you think this is in. If sine of theta is negative and cosine of theta is positive, which quadrant is that? This is a cool question here. I like this one. And there's a couple ways to answer this question. I like these questions. So one way to do it, I'm going to go for a complicated way just to start. And then we'll look at a simpler way, I guess. So here's the sine function. And this is not too complicated. I mean, you should know what the sine function looks like. It looks like this. And this, in a sense, will be a very nice way. And then the cosine function, I'll put big dots for the cosine. So where is the cosine positive and the sine negative? A couple people answered in quadrant 4, I think. And quadrant 4 is correct. Because cosine is positive, it's above the x-axis, and sine needs to be negative, sine needs to be below the x-axis, and that's true there in quadrant 4, between 3 pi over 2 and 2 pi. Okay. But yeah, if you wanted to, maybe that's not the way you thought to do it. Maybe you just maybe you remember all students take calculus. The calculus portion there in quadrant 4 tells us that the cosine of theta is positive. And the other two trig functions, sine and tangent, are negative. And so you can do it that way. Yeah, all students take calculus. Cosine needs to be positive, so it has to be either in quadrant 1 or quadrant 4. All trig functions are positive here in quadrant 1, so sine can't be negative here in quadrant 1. And therefore, it must be quadrant 4. Okay, so a little bit of reasoning there can help you with that. And actually, you can also just look at the unit circle. Where is the sine negative? Where are the y values negative, and the x values positive? If you look at any other quadrant, the sine is positive here. That doesn't work. Sine is positive here. That doesn't work. And then cosine needs to be positive. Cosine is negative here, so that doesn't work. And so we're left with just quadrant 4. Lots of ways to do this problem. Yeah, it's a nice little problem. All right. Well, it's 11:18. So let me check who's here real quick. Yeah, I'm just scrolling through the list of people here. So it'll be recorded, so I'll know who's here. All right, so that is the end of our session today. Are there any last minute questions here? I will be back on Wednesday. So on Wednesday, we can prepare just like a usual exam. It will be given in class, and you'll take it, and then there will be an online portion that you can complete before class or after class. All right. Oops. Yes. Okay. So, will I have Zoom office hours tomorrow? Yes. My excuse me. My 9 a.m. office hour will be on Zoom, and my 3:30 p.m. office hour will also be on Zoom. And then if you email me about taking a quiz or something like that, yes, we can figure that out next week. Because yeah, I haven't been on campus, so but you can come to my office next week and do that then. Okay, and then somebody asked, what is the purpose of all students take calculus? So yeah, I mean, we're basically done, right? I think it's already yeah. So if you have any questions, feel free to stick around and I'll try to answer all your questions. But if you're, if you're good and ready and you're ready to show up on Wednesday, just I'll see you on Wednesday. Okay, so I hope you all have a good day. Um, I'll answer this question here. The all students take calculus. Um, that's just to figure out, it's just a short acronym for figuring out when a trig function is positive and negative. And we can actually do part B of this problem if you'd like, to show, how that's used. Part B is this one here. And all students take calculus tells us, notice that here we want cosine to be positive. Okay, so cosine being positive occurs in the fourth quadrant, but it also occurs in the first quadrant because this all here indicates that all the trig functions, sine theta is positive, cosine theta is positive, and tangent of theta is positive. And so for this problem, we want cosine to be positive, which occurs here in the all and in the calculus portion, but we also want tangent to be positive. So tangent is actually negative in the fourth quadrant. So we can't be talking about quadrant 4 because it's negative there. But in quadrant 1, all trig functions are positive. Therefore, tangent is also positive in quadrant 1. And so the answer to part B is quadrant 1. Okay, so all right. Yeah, have a good day. Thank you. See you next time. Yeah, feel free to stick around, but you're good to go if you have your question answered. All right, yep. See you on Wednesday. And then somebody asked, is this exam considered the final for this class? I would not say that. No, it's just a third exam. Like, so the way that it is on the syllabus is just, it's the same as exam 1 and exam 2. It's just exam number 3. It is the last exam that we will have for this class. So there is no final in a sense. But it's not weighted more than the other exams. It's going to be, so it's just like the other exams. You want to, yeah. All right, you're welcome. Yeah, you want to take it just as seriously, as exams 1 and 2. They're all equally weighted. All right. All right. What other questions do we have? We've still got just 3 people here. If you have any questions, feel free to let me know. I'll stick around for a few minutes. To answer any questions. But if there aren't any questions, then we can also end here. That's fine too. All right, Sergio, you're the last one. Are you still there? All right.